Hello, everyone. What do you think? This yesterday exam, hard, easy, or okay? Okay. Hard, easy. Okay. Okay, listen. I have a score. I will send out of the class. I have a score. And the overall class did a pretty good job. Very good job. Okay, you will see. We have totally 34 questions. We have so many get a perfect score. Some miss one. We will see. The average, I think, is 30 something, 30 out of 34. That's amazing. That's amazing. Right. We will see. Just wait. Just wait. After the class, check your email. After the class, give me 5 minutes. I will send out. Okay. Yeah. Uh, this Sunday, we have office hour. If any question you want me to discuss in the class, send me email. You said, okay, I want you say you look at the class of question 5. I will do that. Okay, this is Sunday. We'll do that, right? And by the way, the some questions just like our did homework, right? Just like we did homework. So which means each week we need to complete our homework with high quality. If you do well in your homework, you reviewed, then you should get. You miss one or two, that's normal. Right? Make some silly mistake, that's normal. We're going to learn it. Okay. Now, so last week we accomplished a lot. We discussed by solving Schrodinger equation, we get 3 numbers N, L, M, L. And each orbital need 3 numbers. Each orbital needs 3 numbers. N, L, M, L. And principal quantum the number, right? L, magnetic quantum number, angular, right? And ML. What's the ML? Can you tell me? Magnetic quantum number. Remember, huh? And that 3 numbers, N, L, ML, right? And N is related the shell of an atom determine the size and the energy. Principal quantum number, right? And L, it is a subshell of the shell. Determine the shape in a subshell or the shape of an atomic orbital. ML, magnetic quantum number, to determine how many individual orbitals within a subshell. Right? Now, let's do some practice. Let's go to sample 1. Give you a minute. Thank you. Thank you. Thank you. Okay. Each atomic orbital, how many number do we need? Each atomic orbital, how many numbers? Three, right? Three. In the page 54. It's a three numbers. If you said it's a 4D, how many numbers? Luis? 4D, how many numbers? Two numbers. So if you said 4D, that's not right. You should say 4D minus 1. So which means N equal 4, L equal 2, ML equal minus 1. That is right. So your answer should be 4D minus 1. That's one orbital. If you said 4D, which means that's 5 orbitals. You 5 orbitals. So ML equal minus 2 minus 1, 0 plus 1 plus 2. Got it? Go to sample 2. Sample 2. Please. Thank you. Now you get it right. Now you get it right. Now if 3p is not right. See, N equals 3, L equal 1, ML equal minus 1. Should it be 3p minus 1? Remember, see, 3 quantum number determine an orbital. 3. Let's go to next one. Give you a minute. Yeah, 3p minus 1, that's right. 3p minus 1, or sample 2. Thank you. Good job. Good job. Okay, let's do that. How many orbitals within a subshell L? And that orbital should be 2L plus 1. When L equals 0, so you have one orbital, that should be S. Why? Because ML equals 0. When L equals 2, you should have 5 orbitals. It should be D. Because ML equals minus 2 minus 1, 0 plus 1 plus 2. When L equals 1, should be 3 orbitals. It should be P. Because ML equals minus 1, 0 plus 1. When L equals 3, should be 7 orbitals. And that one should be F. ML is minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Okay? Right? Now, if you have a question, send me email or come to the office. I will help you. Yeah. If you miss the class, you are going to get the recording catch up. If you miss your homework, I want you catch up. Right? Got it. Now go to sample 4. Let's go to sample 4. Give you a minute, 2 minutes. When you catch up your homework, I want you to do by class date. I want you to catch up the earliest homework first, then up to today's homework. Thank you. Good job. And also we are review here too. I help you review, right? Yeah, here also is a review. Okay, let's do that. So the question said, n equals 7. How many value L? N equals 7. And L equal what? 0, 1, 2, 3, 4, 5, 6. Should it be 7 value? So in other words, n equals 7. We have a 7 subshell. L is a subshell, okay? So that's the A. Now look at the B. 6D, L equal what? 6D, L equals SPD2. Right? L equal 2. How many value ML? ML equal minus L. 0 plus L. So should it be minus 2 minus 1, 0 plus 1 plus 2. C. How many ML? 3P. 3P, which means L equal 1, ML equal minus L, 0 plus L. Should it be minus 1, 0 plus 1? Now go to D. how many subshell when n equals 4? And that basically is how many L equal 0, 1, 2, 3. So you have 4 subshell. And that 4 subshell has a name: 4s, 4p, 4d, 4f. If I ask you how many orbitals, and that is 1, 3, 5, 7. Right? And that orbital we also can give the name. So that should be 4s, 4px, 4py, 4pz. Now for D, it's a 4dxy, 4dyz, 4dxz, 4dx squared y squared, 4dz squared. Now that one should be 4f minus 3, 4f minus 2, 4f minus 1, 4f0, 4f plus 1, 4s plus 2, 4f plus 3. Right? Oh, the file is too big, frozen. Now, give me a second, okay. It's frozen now. Okay, give me a second, okay. Yeah, I may, oh, here it come. There's 3, okay. Any question? Any question, please? Now, go to last one, 2 minutes. 2 minutes, okay. How many subshell and orbital n equal 4? Now let me download another document. Okay. Yeah, give me a second. Okay. Download another document. See. Okay. I will download it. Okay. Hold on. They do not have it. Okay. No. Not it. Okay. Cancel it. Cancel it. Go back to here. Yeah, I will download next week. I'm going to split this document. Okay. Okay, very good. Now I'm going to do that. Okay. Sample 5, n equal 4, how many subshell? And n equal 4, we just did, right? L equal 0, 1, 2, 3. And the subshell should have a 4. That subshell should be 4s, 4p, 4d, 4f. Now, how many atomic orbitals? 1, 3, 5, 7. If we add, that equals 16. So it should be 4 squared. Should it be n squared? Now n equals 6. How many orbitals? "36. Any question? Any question, please? Now, 2L plus 1. 2L plus 1 is that in the subshell. Subshell, how many orbitals? Right. 2L plus 1 is a subshell. How many? It's not, here it's a shell. Right. Now, some of you send an email, said, don't understand this one. I will suggest you go back to review, you come to the office hour, I will help you. But right now, you send a message to me, say you do not understand. We will not go back from beginning to discuss, okay? Yeah, I will help you. Go back to review, okay? Right. Yeah, I wish you send this message to me much earlier, and you did the homework. Last week you did not do the homework. You send me a piece of the paper, only write 5 words. I remember you. Yeah, you only write 5 words, did not do the homework. Yeah, come to the office, I will help you, okay? Or send me email. Any questions so far? Okay, now, so when we discuss orbitals, we discuss the node, right? Can anyone tell me the node? What is a node? The node is that the probability find the electron in that area equals 0. Now, that's the node, such as see, look at the wave. Can you tell me how many nodes? How many? So 1 is here, 1, 2, 3, 4, 5. You have a 5 node. As you know, math, right? Here is a plus, here is a minus, but between plus minus, that line equals 0. Find the electron in that point equals 0. That's the node. Now, the atomic orbital is a 3D. See? And that's why it is a 3D orbital. Now, in this one, based the Schrödinger equation, H per psi, E per psi. Now, what does it mean per psi? Per psi, it is atomic orbital. It's a wave function. In order to easily understand the node, we are going to group or divide this wave function to 2 parts. One is related radius, the size. Another one related only the angle. So we have 2 different types of node, and related the size, that called radial node. Radial node depends on N and L. Now, the node related angle, we call the angular nodes. And that node related L and ML. Now, class, so in terms of node, we are going to divide the two. And what's the purpose? That one easy to understand. One is related the size. See, related the size. Another related angle. Got it. See, look at here. Look at the size. See, from here to here, can you see? And its angle, see, you have two different angles. It's a theta and a phi. Related size, the nodes, it's called angular nodes. And here's angular nodes, it's total nodes. Total nodes equal n minus 1 total. Total nodes is n minus 1. And radial nodes equal n minus L minus 1. Now, can you tell me what's the angular nodes? Because the total one, n minus 1 minus n minus L minus 1. Do the math. Do you think it's L? Yes or no? Now, can you make notes? Can you make notes? Now, in the future, we will discuss more detail. Right now, in this level, that's enough. So we divide the Schrödinger equation to two parts. One is related to size, radius. One is related to angle. Right? So the total nodes n minus 1. Angular nodes n minus L minus 1. The angular node or nodes is L. Any question, please? Any question, please? No? Now let's move on. A little bit, the document, I need to divide the two smaller documents. Now it's too big. Now let's move on. Okay, see? The total number of nodes is n minus 1. Now go to next one. See? The radial nodes is m minus L minus 1. And the angular nodes is the total nodes minus radial nodes, and which should be equal L. Can you go to your class notes, page 58? Now, finish this one. I give you 4 minutes. Yeah, you do not need to send out. Just do your work. Once you're done, we are going to check, okay? Yeah. H, you think we learned the H, right? Thank you. Do you need more time? How many more minutes? A minute. Okay. A minute. Okay. Thank you. Okay, I'm going to do that. Okay. Yeah, I'm going to do that. Now, the nodes, you have two parts. Now, someone I don't understand what's the angular nodes and radial nodes. The radial nodes is that, let me show you radial nodes. Radial nodes is the nodes, it's a secret ring. So when R, the distance in that one, like a sphere surface, there's no electron. Did you remember last time we discussed 1s? So let's go back. Let's go back a long time ago. When we discussed orbitals, see? And that one is radial nodes. Can you see? See, this is sphere. If you cut the sphere, you get what? You get circle, the ring. The radial nodes is here. See? See, that's another one. That's called radial nodes, related size, such as from here, see, here is a node, here is a node. That's radial nodes. Got it. Right, now go to next one. We'll go back to practice. Now, angular nodes is what? So basically, it's a planar, such as you look at a P. From this positive to negative, you cut, you get a plane. On this plane, that equals 0. Now, how I can calculate? The way to calculate is that Radial nodes equal n minus L minus 1. Angular nodes is L. When you add this one, you get the total nodes equal n minus 1. That's the way to calculate. So basically, this one, I'm going to do that, okay? 5D L equal 2 n minus 2 minus 1. 5 minus 2 minus 1, 2. L equal 2. The total nodes is 4. Any question? Any question, please? Now, let's move on. 12F. N equal 12. N equal 12. L equal what? 3. 12 minus 3 minus 1, 8. L equal 3. The total equal 11. Right? Now, the nodes, you look at the nodes equal n minus 1. N, at least n equal 1, right? The nodes should be some orbital, there's 0 nodes, such as 1s. That the nodes is 0, not negative. Do the math. You do the math. Total node, that's a good thinking. That's a very good thinking. We're not in negative. Now go to next one, 2s. 2, 0. And that one should be 1. This one should be 0. And the nodes should be 1. Got it. Oh, how to calculate? Okay, the calculator, see, here, give me the formula to calculate. We should know the NL. That's for the radius. Angular nodes L, you should know what is L. Total nodes N minus 1, you should know the N. What is N? We did the last class, we review today. I'll go to next one. Such as 4D, N equal 4. D, 0, 1, 2, and that should be 2. And it's a node. That node is what? 4 minus 2 minus 1 should be 1. Angular nodes L should be 2. Total should be 3. Any question before I move on? Getting better? Class? Understand? Oh, okay, very good. You understand it. Very good. Very good. So as long as you just, get help, put a little bit of effort, you will do well. Because every year, someone has this feeling, oh, this is so hard, I cannot do that. However, I strongly believe you should be able to do that. L, how do you get L? Okay, now L, did you remember? L equal what? 0, 1, 2, 3, 4, n minus 1. That's the L value. But L use letter. So 0 S, 1 P, 2 D, 3 F, 4 S, P, D, F, G. How did you get L? When you see the letter, you should know the L, such as D. What's the L? L equal 2. Now, 7D, that's the D is what? The D is a 2. 7, the node, 7 minus 2 minus 1 should be 4. again, will happen again. Some of you, I want you mute your computer. We happened a couple weeks ago. Yeah, please mute your computer. Okay. Yeah, you also in the class you listen to the music. In the class you supposed not to listen music. You are in the class. Got it. Appreciate your help. Now go to next one. Angular, of course, it's a 2. Angular is a 2. Total is what? Total should be 6. Total should be 6. Now go to next one. 9. H5. You minus, you get 3. Now it's a 5. So total is what? 8. Right? Got it? Now go to next one. Before do that, let's look at the relationship. L equal what? The angular nodes, that should be same. See? Do you see? Now, when we add these two, see, you add it, you get what? You get the total nodes. How did you know n? Here it's n. Got it. Right. Now, we'll take a time. This is a number game. Now, next one, I'm going to quickly finish it, okay? So 6p, that should be 6. Now you compare your answer, okay? You compare your answer. If you have question, we can discuss. 1, 4, 1, 5, 6D, 6, 2, 3, 2, 5, 12P, 12, 1, 10, 1, 11. Now you have n equals 3, L equals 2. That should be 3D. N equals 7 should be 7. L equals 4. That should be G. N equals 5 should be 5. L equals 1 should be P. Then you add, that should be 2, 6, 4. Question. Okay, now we are move on. Okay. You got it? Okay. Now can we treat sample 2 as an exam? I give you 3 minutes. Treat it as an exam. No, you do not need to have to. Okay. Just focus your work. Yeah. You do not have to send your results. Okay. Oh. 2 more minutes. Very good. Yeah, if you are done, double check your work. Okay. Yeah, double check it. Make sure all get right. Very good. Yeah, double check it. Thank you, Katie. Good job. Yeah, last minute. No, you do not have to. Yeah, no. Double check your work, please. Yeah, yeah. Okay, let's do that. Okay. So remember how I'm going to determine the nodes. The radial nodes, n minus L minus 1. Angular nodes is L. Total nodes is n minus 1. So in order to calculate the nodes, we needed to determine what's the n, what's the L, right? Such as 1s, n equal 1, L equal 0. Now let's do that. I'm quick finish it, okay? I'm very quick to do that. Let's see. Here it's 1, 0, 0, 0, 0. Did you see? The total nodes can be 0, cannot be negative. Thank you for the question. Yeah, cannot be negative. Why? Look at n minus 1, n, the ground state n equal 1. The smallest number should be 0, such as 1s, the node equal 0. Right? Now go to next one, should it be 2, 0, 1, 0, 1. 6f, 6, 3, 2, 3, 5. 2p, oh no, 3s. 3s should be 3, 0, 2, 0, 2. 2p, 2, 1, 0, 1, 1. 8g, 8, 4, 3, 4, 7. 3p, 3, 1, 1, 1, 2. 3d, 2, 3, 3, 2, 0, 2, 2. Just the game. Any question? How many get perfect, please? Wow, I know. Fun, huh? It is a fun part. Okay. Now this one even harder. This one even harder. Okay. I give you 3 minutes. 3 minutes. Okay. This even harder. You put the number, you put the letter. Even harder. This is a hard one. This is pretty hard. Okay. Double check it. Double check it. Okay. You still have 2 minutes. Okay. Yeah. So the first line help you already finish, right? Thank you. Last minute. Okay. Yeah. If we are done, you double check it. Yeah, it's fun. Of course. Of course. Each class just give you some time to learn, to practice, to review. Are we done? Yes, I'm going to do that. Okay, I'm going to do that. Okay. Yeah, I'm going to do that. You see, if you haven't done this, fine. Make notes, okay, and then we will discuss. Again, see, look at this table. All is about the quantum number, the angular momentum quantum principal quantum number n, angular momentum quantum number L, nodes, radial nodes, so which equals n minus L minus 1. Angular nodes should be L, so that should be always the same, right? So you look at the first one, 5D, which means n equal 5, d equal 2, angular nodes 2, radial nodes total should be 4, n minus 4, then that should be 2. That's the way to do that, okay? You got it? Now, just like a very simple math. So in this one, you have 8, 12. The total nodes should be 11. Agree with me? Now, radial nodes 8, that should be 3. The 3 should be F. So here should be 3, and there should be F. Now, n equal what? N equal 12 is a 12F. See, you will find these numbers, okay? Go to next one. The radial nodes here is what? N equal 2. Now total nodes should what? That should equal 1. Now that nodes should equal 0. Because it is 0, L should be 0, right? And that should be 2p. Any question, class? Any question? Do you have question? Oh, no, not a 2p, sorry. It should be 2s. Sorry. Yeah, that should be 2s. Okay, 2s. That should be 2s. Thank you. Good job. Good job. Any questions so far? Now, can I finish the rest? Quick, do that. Okay. Right, you got it? Yeah. So that one should be 3, 1, 2, 4, 2. And there should be 4D. Should be 6, 4, 2, 7, 2, 2, 2. And there should be 7D because you get 2 should be D. 8, 3, and here should be 5. And this one should be 9. That one should be 5. And it should be 9H. Little bit of challenge, but it's okay. So next one, 5. That should be 3. That should be 6. That should be 1. It should be 1. Should be P. 6P. 6P. 3. This one. Oh, that one should be 4. That's right. Should be 4, right? It's right. Read your notes. That one should be 4. That's right. It's right. That one should be 4. Now go to next one. That one should be 5. 2, 6, 2, 6D. 11, 10, 1, 12, 1. 2, 0, 2, 3, 2, 3D. 6, 2, 4, 7, 4, 7G. 4, 3, 1, 5. That should be 5P. Do you have any question for me? How many get a perfect? Okay. Okay. Thank you. Thank you. Good job. Good job. Okay. Oh, thank you. Now, let's do that. So we finish. We finish the 3 quantum numbers. Can anyone tell me which 3 quantum number? Anyone? N, L, M, M, L. The principal quantum number, the angular momentum quantum number, and magnetic quantum number. Very good. Now, an orbital requires 3 numbers, not 1, not 2, not 1, 2, 3 numbers, N, L, M, L. We did a lot of practice today. Then how about electron? So we are going to discuss electrons. Electron need another number. We need another number, that number called electron spin. Remember what we did? We solved Schrödinger equation H per psi, E per psi. We get 3 numbers. However, for the first number, we called MS. This number is not from mathematically calculation. This one, it is from experiments. From the experiments, okay? So look at, see, Schrödinger calculation for energy of hydrogen orbitals. So you see what? NLML, it is a milestone in the atomic theory. It's really cool. This is not a Bohr model. This is based on quantum mechanics, wave function. However, so in the 1925, when these two people look at atomic spectral line, what is the atomic spectral line? Do you remember? Yes, very good. Now let me ask you, for hydrogen atom, yeah, that's right. It's emission of the light. Beautiful summary. Beautiful summary. For hydrogen lamp, how many colors in the visible light? 4. That's right. Perfect. Perfect. For hydrogen, right, it's 4. Hydrogen lamp is 4. And that have a color. So the other color is what? This emission spectrum. See? Now, when these two people look at atomic spectrum line, it's a sodium. When look at this one, what does it find? They find very small deviation. This is another beautiful science. So most of the time, when we find some deviation, we just say, I don't care. Give up. Go away. Now these two people try to find out why you have a smaller deviation. And later on, he found sodium, silver, not the sodium, it's a silver, MAG. He found that tiny deviation because of electron behavior. It comes from electron. And the proposed electron can spin. Electron, just like a spin sphere. And that spin, just like plane rotation on his axis. That spin is related to electron, not orbital. Orbital cannot spin. Electron can spin. You can spin. Your house cannot spin. Now, based quantum mechanics, electron have 2 spin states. We are going to use in a minute. We use arrow up, arrow down. Or we can use alpha or beta. Or we can use clockwise, counterclockwise. Let's look at it. See? Here's the electron spin. So in this one, see, we give the fourth quantum number, we call it MS. So only 2 numbers. One is a plus 1/2, another one is minus 1/2. So you have only 2 numbers, which is the first number we call the spin magnetic quantum number. So you have plus 1/2, minus 1/2, or we can use alpha, beta, or we can use up. This one is down. Look at the spin. So this one is clockwise. This one is counterclockwise. The first number is related electron. It's an electron spin. That number is called the spin magnetic quantum number. That's it. So far we finish the 4 quantum numbers. The first 3, N, L, M, L. That number come from H psi, E psi. And for N, you get what? 1, 2, 3. For L, 0, 1, 2, 3, N minus 1. For ML, you got minus L, 0 plus L. For MS, it is from experiments, and that is a plus 1/2 or minus 1/2 or alpha or beta or up or down or clockwise, counterclockwise. So most of the time, we will use this two. We will use this two number, use this one, or alpha, beta, or use up and down. Lecture have two spin. Any question, please? Any question, please? Now, when you use alpha, beta, not have to clockwise and counterclockwise. I know the document is too big. Next class, I'm going to divide the document to smaller files so that we're not frozen. Now it's okay. Yeah. They're too big. You know how much this chapter is a huge chapter, like 130 pages. Yeah, I need to divide it to 3 smaller files. Should be fine. Okay. Yeah. Any question? Now let's move on. Let's move on. Up this point, what we did hydrogen. Hydrogen, how many electrons? Hydrogen only has 1 electron. Hydrogen only has 1 electron. See? So you have 1 proton, you have 1 electron. So that the interaction, there's only 1 interaction. And that interaction is what? Attraction. So you look at hydrogen atomic structure, atomic orbital. Look at here is NH for hydrogen, right? Here is 1s, 2s, 2p, 3s, 3p, 3d, 4s. And in this case, do you think only N determine the NH? Are you with me? Only N determine energy level. So in other words, same N. The orbital have a same energy, 4s, 4p, 4d, 4f. So that orbital we call the degenerate. All orbital in a given principal quantum number have the same energy, we call it degenerate. Now, make a note. Make a note. Right? And when we solve Schrödinger equation, the results and with experimental data, it's matched very well. The results with experimental data very well for the hydrogen. And the reason, as you know that, because you only has 1 proton, you have 1 electron. So the energy level only determined by the N. Now, I want to look at this one. So many multi-electron atoms, multiple, such as helium. Helium have 2 protons, you have 2 electrons. See? And that's the energy level. That model we call the polyatomic atom. Electron more than 1 cannot solve exactly. Why? Because besides attraction, they also have a repulsion. They also have a repulsion, such as, let me show you, such as helium. You have 2 protons, see? Electron 1, electron 2. You have an attraction here, you have an attraction here, but here is what? You have a repulsion. So in this case, we cannot solve Schrodinger equation. We use what? Approximation. And here is energy level. Did you see the energy level? That's the one. So that's the energy level. Now, that energy level not only determined by the N, but also by the L. See, 2s orbital energy lower than 2p. 3p lower than 4p, then lower than 3d. So in this case, what? Not only energy level for more than 1 electron atom, not only by N, but also L. Also by L, okay? Right? See, look at. This is not the case for polyatomic atom. And that energy level will split, such as 3, N equals 3, 3s energy lower, 3p increase, 3d increase. Now, see, that's the energy order. Why is it important? It's important. And next week, we are going to put electron to the orbitals. Which orbital we go first? Can you tell me? Based on energy level. And this go first. S go first. S go first. Then you what? Then you go to P. Then you go to the D. Then you go to the F. Why? When we put the orbital to electron to orbitals, always from low energy orbital go to high. Got it. So this is very important that we'll discuss more. Any question? Now let's move on. Can we go to sample 1? Let me give you 2 minutes. Yeah, look at the question carefully, okay? Thank you. Good job. Good job. Now I'm going to do that. Okay. Yeah. So the first one said hydrogen atom only. True for all, not true for any atom. The principal quantum number completely determine the energy of given electron only for hydrogen. Only for hydrogen only. Angular momentum quantum number L determine the shape of atomic orbital for all. That's a definition, right? Magnetic quantum number ML determines the direction of atomic orbital, the point in the space for all. Also, it's a definition, right? Any question? No, let's move on. Sample 2, you list all possible combination NL, ML, MS. Now it's not. We just said, right? Now go back. Look at the first one. Because it determine for hydrogen atom, the energy level determined by N, only hydrogen. Did you remember? If more than one atom, that the orbital was splitting, right? So you go back and look at here. Oh, where is it again? So you look at here, see? 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. That only for hydrogen. For another one, see, 3s, 3p, 3d. Not only by N, also by the L. Thank you. Now you are going to look at what 2p, huh? Let me give you 1 more minute. Thank you. Good job. Good job. Excellent. I want to use a table format, okay? Yeah. In that case, you will have very nice. Oh, let's look at. I'm going to do that, okay? I'm going to do that. So in this one, I'm going to put N, L, ML, MS. I want to make a note, okay? Now they said 2p. So N equal 2, L equal 1. Now before move on, how many orbitals 2p? 4? how many orbitals 2p, how many orbitals Louis get right? The 3 orbitals, not 8. 2p, there's no any subshell have 8 orbitals. No. Right? That can be 1, 3, 5, 7, 9. Right? Where not 8? Where did you get 8? Where you get a 2? That one is what? It's a 2L plus 1, because you plus 1, you always is odd number. Think about it. Okay? Not the N, I didn't know the N. I said 2p, how many orbitals? See, I write it here. Should be 3 orbitals. Remember, huh? Remember. Now, ML should be minus 1. MS could be minus 1/2. Could be plus 1/2. 2, 1, minus 1. Now, 2, 1, 0, plus 1/2. 2, 1, 0. Oh, that's for the system, okay? The first one I put minus. Here also put the minus, okay? Yeah. That's put the minus. Now that one should be plus 1/2. 2, 1, plus 1, minus 1/2. 2, 1, plus 1, minus 1/2. Any question? Any question, please? Now we're going to discuss your question. This table, let me know. We are going to discuss what's mean. Any question? No, I'm going to discuss this table. Any question? Oh, wow. Give me a second. You know the file again is too big. It's frozen here. Yeah. Wow. Give me one more second. I may come back. Okay. Any question for this table? No, I ask you, no question. Okay. I ask you. Atomic orbital. Need how many numbers? 4? 3, right? 3, right? Now, electron need how many numbers? Electron need 4, right? N, L, M, L, M, S. So here is 1 electron. So now here is 1 electron. 2p orbital, how many electrons can hold? And that one should be 6 electrons. How many orbitals? The 3 orbitals. 6 divided 3 equal what? Equal 2. 2, what's mean? Can I say each atomic orbital can hold 2 electrons? Can I say each atomic orbital can only hold 2 electrons, not 3, not 4. Atomic orbital can hold 1 electron. It's okay. Can atomic orbital have only 1 electron? It's okay. Yes. Yes. Can be 0, can be 1, can be 2, not 3. Most is 2. Got it, Louis? Very good job. Now go to this one. A minute. A minute, okay? Okay, now do that. Good job. Eric, finish. Now use the table format. Use the table format. You will not miss anything, okay? Yeah, use the table format, okay? Okay. Okay, I'm going to do that, okay? Yeah, I'm going to do that, okay? Now tell me 6s, how many orbitals? How many? 6s, 2 orbital or 1? And L equals 0, ML equals 0. It is 1 atomic orbital. It's only 1, okay? Only have 1. How many electrons can hold? 2 electrons. 2 electrons. Okay, very good. Now let's do that. 6s, N equals 6, L equals 0. N, L, M, L, M, S. 6, 0, 0, minus 1/2. 6, 0, 0, plus 1/2. So here is 1 electron. Here is the second one. Got it. So we can say 6s squared. And that square should be 2 electrons, such as in the previous one, we said 2p6. 6s2, 2p6, we are going to use in a minute. Any question? Move on before we move on. Any question now? Any question? You got it? You understand? Very nice. Very nice. We finish. Beautiful work. I'm very happy. We finish. Now what we did? Now let's look at a quick review. So we did NLML. We reviewed before. So here is what? 1, 0, 0. It's 1s. You have 1 subshell. You have 1 orbital, 1s, you can hold 2 electrons. So you get total electron 2. Now move on. N equal 2. L could be 1 0, 1, 2s2p. ML is 3 orbitals. The total, how many? 1 plus 3, it's 4. Electron, 2 plus 6, 8. So here it's 8. Do one more. N equals 3. 1, 2, 0, 1, 2. ML, 0, 1, 0, minus 1. 2, 1, 0, minus 1, minus 2. 2s2p, 2d. Orbital, remember, orbitals always is odd number. 1, 3, 5, 7, 9, 11, 13. See? 1, 3, 5, 7. Next one should be 9. Next one should be 11, 13, 15, 17, 19, 21. That's one. Okay, I'm going to summary. What's this? And that is 1, 4, 9, 16, which is n squared. So for all electrons, should be 2n squared. 2n squared. So n equals 4. How many electrons can hold? You will have 16 orbitals. And you can hold up to 32 electrons. And that 16 orbital is what? It is 4s2, 4p6, 4d10, 4f14. Then you add 2, 6, 10, 14, you get 32. You add. Did you see? Right? We're done. It's really cool. Can we move on? Do you know why we discuss orbitals? The reason we very detailed, we spent 2 hours discuss those orbitals in order to put the electron to the orbital. Right? So we are going to learn electron configuration. Electron configuration. What's mean electron configuration? Determine how to arrange electron to the orbital. Such as sodium. How many electrons, please? Sodium, you have 11 electrons. Now, how are you going to put this 11 electrons to the orbitals? How can you do that? Now, we're going to learn it. We're going to learn it. Let me show you first. That should be 1s2, 2s2, 2p6, 3s1. So, and that's called electron configuration. Very powerful class, William. Why? Once we learn electron configuration, we are going to determine how we're going to lose electron, how we're going to gain electron, how much energy required to lose electron. When we add the electron, how much energy will release? Got it. Got it. It's so cool. So cool. Now you said, no, I get totally lost. No worry, I'm going to teach you. I'm going to teach you, okay, in a minute, okay? Can we move on? Let's move on. Right. So we are going to spend today, next week, we are going to work on electron configuration, okay? Yeah, we'll take an hour. So when we discuss electron configuration, first of all, we have assumed it is a ground state. Why? Because ground state is only one state. If not ground state, excited state, we do not know which excited state is the first excited or second. So we assume electron configuration always is ground state. Now, highlight. So that's why, because energy lower, only one, ground state only has one state. Excited state have affinity. Now, to put electrons to the atomic orbital, have three laws we are going to follow. The first law we call alpha ball law. Alpha ball principle. Each electron occupy lowest energy orbital available. Electron from lowest energy to highest. Now I'm going to, I need your help. I need help, okay? Now, so let's look at n equal 1. What's the orbital? Or what's the orbitals? N equal 1, can I say it's 1s? Can I, Eric? Right, because n equal 1, L equal 1, L equals 0, ML equals 0. So it's only one orbital. N equal 2, what's the orbitals? You should say 2s, 2p. No, do not say sp, 2s, 2p. N equals 3, what's the orbitals? Can I say it's a 3s, 3p, 3d? Okay, now I'm going to finish the rest. Okay. 4s, 4p, 4d, 4f. N equal 5, 5s, 5p, 5d, 5f, 5g. N equals 6, 6s, 6p, 6d, 6f, 6g. N equals 7, 7s, 7p, 7d, 7f, 7g, 7h. Any question? Any question, please? N equals y. N equals 6 here. We do have n equals 6. So 1, 2, 3, 4, 5, 6. H. Oh, hold on. 1, 2. Oh, should it be 6 H and 7 I? Good job. Good job. Okay. Good job. Any question, please? Oh, okay. Now let me erase it. Okay. Let me erase it. Make sure. See, you know why? I also will get very excited when we do this part. Okay. 7s, 7p, 7d, 7f, 7g, 7h, 7I. That's good. Any questions so far? Now I want you see. Okay, I use this color. What's this? Can you tell me what's this? That what can I say? It's right triangle. No, not a triangle, right triangle. It's 90 degree. Yeah. Okay. So order with the case now. When we put the electron, which orbital go first? One s. Now, what's the next orbital? 2s. What's the next orbital? 2p 3s. Oh, no, 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 no. That's not. Hold on. A little bit of freezing. I cannot change the screen. Okay. Yeah, that should be done. Give me a second. Oh, let's slow down. Give me a second. Okay. Come back. Come back. So that should be 2s, 2p. See, 1s, 2s, 2p, 3s. Next one is a 3p, 4s. Next one, 3d, 4p, 5s. 4d, 5p, 6s. 4f, 5d, 6p, 7s. And 5f, 6d, 7p. That's the order put the electron. That's the order we are going to put the electron to the atomic orbital. So here's the order, okay? Now, may I give you 4 minutes, remember this order. There are two ways to do that. One way, see, I give it to you, right? Or you can remember this one. Now, I'm going to give you 4 minutes. You're going to remember it, okay? 4 minutes, okay? Remember this order. We are going to use all the time. Now, there are two ways to do that. You can use C, 1s, 2s, 2p, 3s, 3p, 4s. That's order. Or just direct from here. Go ahead. Go ahead, please. Good job. Oh, let me check. Oh, okay, I can check it for you. Okay. Now can you use a smaller letter? Because see, it should be smaller letter. I want it at the beginning, you get it right. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. Good job. 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s. Perfect. Good job. Good job. Good job. Good job. We are going to use in a minute, okay? Yeah, 2 more minutes. And you try to memorize now. Why? Why? We are going to use it. And when you use it, I do not want you look at your notes. Right? You just memorize, get it right. That's it. Okay? Yeah. 2 more minutes. Okay. Then we'll move forward. Yeah, good job. Good job. Do you have fun today? Yes. Yeah, lots of fun. We learn a lot each class. Yeah, last minute, okay. Last minute. Oh, you got it. Wonderful, wonderful, wonderful. Yeah, also need a review. You review a couple times. Oh, here is one. Very good. Yes. Yes. Perfect. 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 Great. Great. Now I'm going to do that. Okay. Done. So this part we are done. So why is it important? The reason important is that that's the way we are going to put the electron. See, beginning 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, then move on. Or when you look at periodic table, look at this table. See, you beginning here, we will discuss more detail next class. You do not need to memorize, but everyone you can use your table. See, you beginning here, see 1s, 1, 2, 2s, 1, 2, 2p, 1, 6, 1 to 6, 3s, 1 to 2, 3p, 1 to 6, 4s, 1, 2, 3d, 1 to 10, 1 to 6. That's the way to do that. Now, let me write out. See, 1s, 1 to 2, 2s, 1 to 2, 2p, 1 to 6, 3s, 1 to 2, 1 to 6, 4s, 1 to 2, 1 to 10, 1 to 6, 1 to 2, 1 to 6, 10, 1 to 6. Now, 6s, 1 to 2. Now you go to what? 1 to 14. Now, next one, 1 to 10, 1 to 6. That's the order to do that. That's the order to do that, okay? And later on, also we will discuss S block. That's the S block. P block is a P block. D block, F block. Why? Because last lecture, if we put that orbital, we are going to learn that. Remember, degenerate 3p p orbital, you have a 3p NH is the same. 5d NH is the same. 7p NH is the same. That's called degenerate. That called a degenerate orbital, okay? Right? So such as, let's move on. See, in this one, you have a 3p. Here it is 5d. That NH is the same. Now we are going to do some electron configuration. We're going to do that, okay? Now we're going to do couple of. So the first one, I want you take out your periodic table. Take out the periodic table. Hydrogen. How many electrons? 1. So that should be 1s1. That's it. Helium. How many electrons? 2. And that should be 1s2. Next one, lithium. 3. How can you do that? 1s3? No, because, yeah, that should be 1s2. Because 1s only have one orbital, can only put 2 electrons. Now next one, you go to 2 or 2s, but totally 3. The third one put here. Any question? Now I'm going to discuss this one. I'm going to discuss this one. I want you to pay attention, okay? So you have 2 electrons. One has only 1 orbital. That's one possible. Oh. And another one. One, two, three. Which one is right? Which one is right? 1, 2, or 3? It's this. Why? Here. So that's the second principle. Pauli exclusive principle. Pauli exclusive principle. And see, in a given atom, no 2 electrons have a same set for quantum number. Since in the same orbital, NL, ML is the same. So in other words, the first one, MS, should be different. Pauli exclusive principle. Now I'm going to discuss this one a little bit, okay? And they said, in a given atom, no 2 electrons can have the same set 4 numbers. So such as, let's look at, okay? Right? So 1s2 N L ML MS 1sn equal 1 L equal 0 ML equal 0. So that we can say -1/2 based on Pauli exclusive principle. See, 1s should be 1, 0, 0. Now here it's the same. See, and the first one you have to plus. So in other words, if this one is up, this one should be down. This one is up, alpha. This one should be beta. Classic. Did you get it? Did you get it? right? It's really cool. Any question for me, please? Okay. Yeah, you can treat it. This one is alpha, this one is beta. Yes, you can treat it that way. Okay. Okay. Yeah, also changeable. You want to go back to periodic table? Sure. Here. Oh, you want this one, right? Degenerate. Oh, sure. Well, this one too. This one. Any more question, class? We will discuss. Hold on. Yeah, give class some time. Oh, this one, which means that's orbital, right? P, you have orbital. That's a 3D orbital. See, here is a 3D orbital, right? And here is a 5 orbital. Yeah. Here is a 7 orbital. Okay. Or you can use this way too. That's 1 orbital. Okay. Now that's it. Today, because the file is huge, we frozen a couple times, and the next week will not happen. Okay. I'm going to send your score from yesterday's exam. Class did very well. Okay. Good night. Bye now.
Bye.
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 Bye. Thank you.